I really hope YouTube lets this be the video thumbnail, because if not, what's even the point? Let's do some calculations. So by the time you're seeing this, we would have done some work with this on Friday. It's now Monday. We're going to do some in class this afternoon. By this time, I'm giving you, I think it was 14 questions to do just as a practice that I can walk you through. You can do on your own and compare and see how you actually do with these things. So remember, for the mole calculations, we have this one equation up here. That's in the back page of your reference table on table T. It says that the number of moles, which is again a word that means something like a dozen means 12, or a ream paper is 500. The number of moles is equal to the given mass, how much you actually have of some kind of substance, divided by the gram formula mass, or how much 1 mole of that substance weighs. So the gram formula mass can be seen on the reference table. If you go to the periodic table, it shows it up here. You can take this mass right here for any element. For a compound, you just add the numbers up, as we've been doing for the last couple of weeks. That's your gram formula mass. How much does 1 mole weigh? The given mass, again, is going to be how much you're told you have of something in a question. So let's look at the actual questions and get started. Remember, you do also have these triangles up here. This mass formula here, and only refers to mass, that will match this triangle here. The other two triangles are the same basic equation, but this one is for volume, so it's liters, and this one tells you the number of atoms or molecules or whatever. But this triangle here that we'll see the vast majority of, that's going to be related directly to that formula that, again, is on the back page of your reference table. So let's see what the question says and see what information we need and what we have to find. So the question says, what is the mass of 4 moles of helium? And tells us that is H8. That's the formula for the element helium. So it tells us mass. We're looking for the mass. So that's now going to eliminate these two triangles because they have liters and number of atoms. We're going to use this triangle here that says mass. And again, that relates directly now to our formula over here, because that talks about mass in these two parts of the fraction. So what is the mass of 4 moles of helium, H8? We're going to use this equation up top. I'm just going to write it down here. Moles is equal to mass over the gram formula mass. So how much mass do we actually have? What weight of this stuff do we actually have present in our hands? Our given mass. And what is the gram formula mass? That is how much does 1 mole of that thing weigh. So we are told we have 4 moles already. So that's what we're going to fill now in over on the left. So we're going to have 4 is equal to mass over gram formula mass. Now the question says, what is the mass? That's what we're looking for. That's the thing we don't know. So I'm just going to leave that as blank. That's our mass. That's our unknown. So we've got the 4 moles over here. We've got mass on top of a fraction. And we now need to know what is the GFM. We can't have two unknowns in the formula, so we have to have something we can look up. The GFM you can always look up because, again, that's just on the reference table. You go to your periodic table, and this right here tells you what the GFM is. 1 mole of helium weighs 4.00260 grams. Work around it off to 4. And our formula right here for helium says it's just 1 He. It's not a compound, it's not a molecule of more than one thing. It's just one thing of helium. That's going to weigh 4. So I'm going to write that down here now in my fraction. It's 4. If you want to get a little bit more technical, you can write that it's 4 grams per mole. And this really up here is mass in grams. And then we do our math. We've got 4 equals what is essentially x over 4. To do this, we can cross multiply. I'm going to multiply the 4 by the 4. I'm going to multiply these two things. So 4 by 4 is 16. And that's going to equal this unknown that we had over here. That's going to be my grams. The mass is equal to 16 grams. If you want to double check the math, you can just plug the numbers in. 16 grams divided by something that weighs 4 grams for every mole. 16 divided by 4 equals 4. These grams cancel each other out, and the unit of measurement you're left with right here is moles. So my answer ends up being 4 moles, which is exactly what I started with over here. So that makes sense. 16 grams is the mass, and that's my actual answer to this question. The question asked what is the mass, and the mass was 16 grams. I have 16 grams of helium. 1 mole of this stuff weighs 4 grams. So how many moles do I actually have? Again, that's like saying in the example we showed the other day, if we know each donut weighs half a pound and we have 2 pounds of donuts, well, how many donuts is that equal to? It's just you know what one thing weighs, you know what you have in total, divide them and see how many that it comes out to. Now just quickly, we can use the triangle the same way. This triangle up here, we can do mass moles and GFM the same way we just did it on the other with the actual equation. Again, we had 4 for the moles. I'm going to write a 4 right there. We knew our GFM from right here was 4, so I plug that number in. Remember, with the triangle, you would cover up what you don't know. So in this case, I can't really show you where my thumb is going, but I would cover up right here where the mass is. And then the only numbers I'm left with are 4 and 4 on the bottom. You multiply when things are next to each other. You divide when it's top to bottom. So I'm going to do, again, just 4 times 4, and that equals 16 in the same way that our answer was already 16 down here. So 16 grams is our mass. And we get the exact same answer, whether using the formula up top or if you're more comfortable using the triangle. Just notice again that these two triangles over here are the same basic layout as these things, but you don't really have the formula for them. Only the mass formula right here is on the reference table. So if you're comfortable with that, great. If not, you always have the triangles you can use. That took 6 minutes roughly to do this first thing, so let's go a lot quicker going forward. Same process, same formulas and everything. This one says how many moles of carbon dioxide, and that's CO2, are in a 22-gram sample of the compound. I've given you the tiles for these couple of elements over here that we need, but I'm not going to give them for every single slide on here because that'd just be a waste of time. I want you to actually go and look these things up. So how many moles of carbon dioxide are in a 22-gram sample of the compound? I'm going to write out my formula, and that is just moles equals grams over gram formula mass. How much do we actually have of something, the grams, divided by how much does 1 mole of that thing weigh, the gram formula mass. How many moles? That's what the question starts with. So I know in my equation that's going to be my unknown, so I'm going to leave it as moles. That means we have to have these two other things because we can't have more than one unknown. Carbon dioxide is what I'm working with. That's going to be my compound. It says are in a 22-gram sample. There's the bell. I'm going to finish this quickly. 22 grams, that's what I physically have of something. 22 grams go on top. The bottom of the fraction says gram formula mass. That's how much 1 molecule, 1 mole of this thing, I should say rather, weighs. Each carbon weighs 12. So we're going to add everything up. Carbon equals, there's only 1 carbon, and each one of them weighs 12. So that's 12 total. For the oxygen part of the molecule, there are 2 oxygens, and each one of them right here weighs 15.9. We round that to 16. So the 2 oxygen parts weigh 32. I'm going to add up my 12 and my 32. So the entire carbon dioxide thing, 1 mole of carbon dioxide, that's 6.02 times 10 to the 23rd molecules of carbon dioxide, weigh 44 grams per mole. I can now plug that number in down here, 44 grams per mole. That's my GFM. And I've got my calculator out here. I'm going to do 22 divided by 44. And that is going to give me an answer that this much carbon dioxide, if I have 22 grams of it, but 44 grams is a mole, that's only half of what I need to count as 1 mole. So it's going to give me 0.5 moles of CO2. That's like saying something weighs 44 pounds. If you only actually have 22 pounds of it, you only have half of what you'd expect. So it's 0.5 moles of carbon dioxide is equal to this 22-gram sample of carbon dioxide. I need to get to 4th period, so I'll continue this a little bit later. Okay, let's see how many more of these we can get through before the end of the day, and then I may just have to post up an answer key without the actual video. But third example, how many moles of carbon tetrafluoride CF4 are in 176 grams of CF4? We're going to do it the exact same way we've been doing. Moles equals grams over gram formula mass. The given mass, how much you actually have, divided by how much each mole weighs. How many moles? That's what we're looking for right here. That's going to be our unknown. So I'm going to write it again over here. Moles equals, now it tells us we have 176 grams. That's what we have. That's our given mass. So 176 grams is the top of my fraction over here, divided by the GFM. So I need to go look up what CF4 weighs. And if I go to my reference table, carbon, there's 1 of it in the molecule, and each one weighs 12 according to my periodic table. So that accounts for 12. And F, there are 4 Fs in this molecule, and my periodic table tells me that each one weighs 19. So that's going to give us a total mass of 76. And when we add these two numbers together, 12 and 76 come out to 88. So that is my GFM for CF4, is 88. So I'm going to write that right here. I'm going to write 88 grams per mole. Like that 88 grams per mole. So 176 divided by 88, and that's going to come out to tell me that my moles equals 2 moles of CF4. If I have 176 grams and each mole weighs 88 grams, I have exactly twice as much as 1 mole, so that means I have 2 moles of CF4 contained in that 176 grams of CF4. Number 4, what is the mass of 0.5 moles of carbon tetrafluoride CF4, the same compound we just saw? So once again, I'm going to write moles equals grams over gram formula mass. In this one now, it tells us we have 0.5 moles. So I'm going to write 0.5 over here on the left equals grams over gram formula mass. It asks me in the question, what is the mass? That's going to be the grams right here. That's going to be what I'm looking for. If I'm looking for that, that's going to be my unknown. It means I have to know what the GFM is. So I don't have that in the question. It doesn't tell me what the GFM is, but I can always go look up what the GFM is. I have to see what CF4 weighs, and luckily we just did that in the last question. So I still have it written down here that CF4 weighs 88 grams per mole. I'm doing terrible at writing these 8s today. Oh well. 88 grams per mole. That's what 1 mole of CF4 weighs. So to do this now, we just do 0.5 times the 88. If you had done it on the triangle up top here, you would have written 0.5 right here and 88 in the GFM. And then you're looking for mass, so you kind of cross that off. You multiply the two things on the bottom. Either way, it comes up to 0.5 times 88. So what is half of 88? And that is going to be 44 grams of CF4 in your sample. That would be the equivalent of 0.5 moles, because 1 mole weighs 88, so if we only have 44, that's half of 1 mole, the 0.5 moles to start with. You can plug these numbers in, double check your math if you have to, but 44 grams is equivalent to the 0.5 moles in the question. A little bit bigger of a question here just because the molecule is a little bit bigger, but the same process still. So we still have moles equals grams over gram formula mass. Let's see what the question actually tells us. It says they need 3 moles of aluminum oxide, so that's going to be our mole number here. So 3 moles equals grams over gram formula mass. And the question says, how many grams should she weigh out? So that's going to be our unknown right here. The grams is going to be what we're looking for. So we need to find the gram formula mass ourselves and plug that number in. So I'm now going to add up what Al2O3 weighs. For the Al, there are 2 atoms. Each one of them weighs 27. So it's going to add up to 54 total. For the oxygen, there are 3 oxygens, and each one weighs 16. So 3 times 16 means the oxygen part of the molecule is going to weigh 48. I just add those 2 numbers up, and I see that my entire molecule is going to weigh 102 grams for every mole of Al2O3. Now I can plug that number in down here. I'm going to erase my GFM and plug the actual number in. So I'm going to write 102 grams per mole of Al2O3. I can divide these, multiply these numbers now. 3 times 102, and that is going to give me 306 grams as an answer of Al2O3. If I have 306 grams of Al2O3 and each mole weighs 102 grams for Al2O3, that would come out meaning I have 3 moles. I did the math backwards, so if I have 3 moles, I know that's the equivalent now of something that weighs 306 grams of this compound Al2O3. Number 6, what is the volume of 9.2 moles of propane gas, which is C3H8? Right away we see what is the volume. This is a different type of question that we've seen in the last couple examples. So we need to use a different triangle now. We're finally going to use this middle triangle. So I told you there were 2 examples from the homework I want you to look at with volume, and this is one of them now. As soon as you see this word volume, and we see this, it doesn't mention the word liters, but usually you'll see the word liters there. We know it's going to be this triangle right in the middle here. It's the only triangle that has anything to do with volume of a gas. So we're going to use it a little bit differently. Let me draw my triangle down here. Moles always goes in the bottom left. The unit you're trying to convert to, the liters, the volume is up top. And at the bottom right, we have our conversion factor, which is 22.4, because 1 mole of any gas is always 22.4 liters. So I plug my numbers in now. What is the volume of 9.2 moles? That's my moles here. So I'm going to erase the word moles and just write 9.2 in. I'm looking for liters, so I do 9.2 times 22.4. If we just multiply straight across, 9.2 times 22.4 is going to equal to 206.08 liters. So I'm just going to round this off and say it's 206 liters. If we have 206 liters, and each mole is 22.4 liters. That's how we get 9.2 moles. Number 7, how many moles of water are in 360 grams of water? Same formula, moles. It talks about grams this time, so we're back to mass. So I'm going to again go back to grams over gram formula mass. The volume question was a one-off thing. There's one more example of it. Mostly we're talking about mass. How many moles of water in 360 grams of water? We don't know how many moles we have. That's what the question's asking us. So our moles is going to be the unknown. So I'm just going to rewrite that over here. Moles, we still don't know. Equals grams of gram formula mass. It tells us we have 360 grams. So that's going to be our given mass. It's going to go on the top of my fraction, 360 grams right here. On the bottom, we have to know what the gram formula mass of water actually is. We can look that up. We take the mass of the 2 hydrogens. Each one of them is 1, so the hydrogen part of the molecule is going to be 2. We can look at the mass of the 1 oxygen. That one's going to weigh 16. So altogether, 2 and 16 gives us 18. That is the mass of 1 mole of water. So it's 18 grams per mole of water. 360 divided by 18 is going to give us 20. Our grams and gram units cancel out, and it's 20 moles. That's what we're looking for right here. That's this answer here. 20 moles of water are contained in a sample of water that weighs 360 grams. Each one is 18, so 20 of them weigh 360. Number 8, what is the mass of 2.5 moles of hydrogen fluoride gas, HF? Same formula, moles equals grams over gram formula mass. We know we have 2.5 moles, so we can write that on the left side, 2.5 moles. Equals grams over gram formula mass. It says, what is the mass? We don't know what our mass is. I'm going to leave that as just G, but we can put it over the gram formula mass of HF. H equals 1. And if we look up fluorine, it tells us that fluorine weighs 19. So altogether, they're going to have a GFM of 20. So I'm going to divide by 20 over here. That's going to be 20 grams per mole. And because we have our 2 numbers across from each other, we're looking for the grams up top. We multiply 2.5 times 20, and 2.5 times 20 is 50 grams of HF. If 1 mole of HF weighs 20, and we have 2.5 moles of it, it's just 20 times 2.5, and that whole sample will weigh 50 grams of hydrogen fluoride. There are sirens outside. Let's do it anyway. How many moles of chromium metal, Cr, are in a 260 gram piece of aluminum? Same formula, moles equals grams over gram formula mass. The question says how many moles? We don't know. That's what we're looking for. Moles equals, do we know how much it weighs? It tells us right here it's a 260 gram piece of chromium. So I'm going to write 260 right here, grams. Gram formula mass, we need to find what 1 mole of chromium weighs. We look up Cr on our reference table, on a periodic table, and it tells us it is 52 grams for every mole of chromium metal. Divide these two numbers, 260 divided by 52 gives us 5 moles of chromium metal. Number 10, what's the mass of 5 moles of nitrogen gas? That's N2. Moles, oh, it's green, look at that. Moles equals grams over gram formula mass. We are told we have 5 moles, so that's going to be my number right here, 5 moles equals grams over gram formula mass. Do I know what the mass is? I do not, because the question says, what is the mass? I'm going to leave that as grams. That means I have to be able to go look up my gram formula mass. I've been doing every single question. So I'm going to look up what the gram formula mass of N2 is. And if you look at N, there's 2 of them in the molecule. Each one, according to our periodic table, weighs 14. So the total mass of N, the gram formula mass, I should say, is 14 times 2, and that's going to be 28 grams per mole for N2. So I'm going to write this down here now, 28 grams per mole. We don't know what grams is. We cover up the top thing, we multiply across, and 5 times 28 is going to give you 140 grams of N2. If each mole of N2 weighs 28 and you have 5 moles of it, then just multiply the 5 by the 28 and tells you your entire 5 mole sample of N2 gas weighs 140 grams. Number 11, what is the volume of a 12 mole sample of argon gas? Now we see volume again, so we're going to go once again back to this triangle here. So I'm just going to draw the triangle. You can write the formula out normally if you want, but the triangle is easy because we don't have it on the reference table. Moles go on the bottom left as always. the unit you're trying to get to, liters goes up top, and your conversion factor, the 22.4, which is the number of liters in a mole of any gas, goes in the bottom right, much like GFM for the mass questions, and you see here Avogadro's number for the molecule and atom questions. I have some numbers here to plug in. It says what is the volume, so this is what we're going to be looking for. We're going to be looking for our liters up top, but we do know the number of moles because it tells us a 12 mole sample. So I'm going to go ahead and rewrite this right here. We don't know how many liters we have. We know it's 12 moles at the bottom here. And we know it's 22.4 moles per liter. So I'm going to multiply across. I could cross out the guy up top and multiply across 12 times 22.4 is going to come out to 268. There's the bell. Day's over. 0.8 liters. So each mole takes up 22.4 liters of space. If you have 12 moles, it's just 12 times 22.4. That comes out to, again, 268.8 liters of argon gas. I've got a faculty meeting in about 4 minutes, but I want to get these done quick, so let's just run through these. How many moles of ammonia in number 12? NH3 are in 51 grams of NH3. Moles equals grams over gram for oil mass. We don't know how many moles we have, so I'm going to leave that blank and just write moles equals how much do we actually have. It says we've got 51 grams. So we're at 51 grams on the top of my fraction. I need to look up how much NH3 weighs. Each of these nitrogens is 14. Each of the hydrogens is 1, so altogether it's 3. 14 and 3 equals 17 as your gram for oil mass. So I'm going to write right there, 17 grams per mole of NH3. 51 divided by 17 is going to give me 3 moles. So each mole of NH3 weighs 17 grams. If I actually have 51 grams, it means I have more than 1 mole. How many more? It's 3 moles total. Number 13 was the mass of 3 moles of carbon disulfide. Moles equals grams over GFM, the gram for oil mass. We know we have 3 moles. So that's going to be this number right here, 3 moles equals grams over the gram for oil mass. The question says, what is the mass? So we don't know what that is yet. We're going to leave the G up top by itself. So we now need to look up what the GFM of carbon disulfide is. Each carbon weighs 12. Each of the sulfurs weighs 32. So 2 of those would be 64. So altogether, the 12 and 64 gives a mass of 76 grams per mole. So I'm going to plug that number in on the bottom of my fraction as a GFM of CS2 and write 76 grams per mole down there. I'm looking for the grams up top, so I multiply across 3 times 76, and 3 times 76 means that 3 moles of this stuff will weigh 228 grams. Each mole weighs 76 grams. If I have 3 of them, it's just 76 plus 76 plus 76, and the total of that is 228 grams for my whole sample. Last one. How many moles of calcium Ca are contained in 1,000 grams of calcium? Moles equals grams over gram for oil mass. It says how many moles? We don't know. Leave that right there. Moles equals tells us we have 1,000 grams of calcium. I'm going to write that up top. 1,000 grams. We need to find the GFM of calcium. I'm going to look at my reference table, and it tells me that if we round it, it is 40 grams per mole of calcium metal. So I'm going to do 1,000 divided by 40, and that tells me I have 25 moles of calcium. Each mole weighs 40. If I have 1,000, that accounts for 25. So 25 moles of calcium in my sample, and we are done. Hopefully this makes sense. Quiz tomorrow.